This is 5.8b of Algebra. So we're going to look at absolute value functions again. So in the last lesson we looked at moving them up and down. Now we're going to look at moving them horizontally, so left to right. So when we're graphing horizontally, you kind of got to think opposites. When you see a plus 5 in there, that actually means that we're going to the left 5, not to the right, right? Usually we assume right with positive and left with negative. Instead, you need to think opposites, and you need to think plus means going to the left and minus means going to the right. And let me show you why that works. So to get this point here, this is the point -5, 0, right? So if we want y to be 0, right, we've got y equals the absolute value of x plus 5. If we want y to be 0, we need whatever is in these absolute values to come out to 0. So we need x plus 5 to be 0. And if we solve for that, we get that x is equal to -5. So that's why we have the point -5, 0. So if we're graphing this equation, y equals the absolute value of x minus 5, we're going to go 5 to the right. So 1, 2, 3, 4, 5. And I can go up 1 to the right 1, up 1 to the right 1, go back to my bottom of my V, up 1 to the left 1, up 1 to the left 1. And there's my graph. So when we have adding or subtracting inside of the absolute values, that's moving you left and right. When it's outside of the absolute values, that's when it's going up and down. Okay, so there's this thing called a piecewise function, and it's a function that has different rules for different parts of its domain. So maybe you have an equation to use when x is greater than 0, and you have an equation to use when x is less than 0, and you have some equation to use when x is equal to 0. Right? There's a bunch of different ways we can do this. One version of a piecewise function is a step function, and that's what you see in this picture over here, right? It kind of looks like stairs. So a step function is a function that pairs every number in an interval with a single value. So every x here goes to 0. Every x here goes to 1 right here, right? Every x here goes to -1 right there. So let's try graphing a step function. So we're going to do the same sort of situation as our problem here. It says a school with charter buses so that the student body can attend a football game. Oh, a school will charter buses. Okay, each bus holds a maximum of 60 students. And they graphed it out here. So we're going to do our own, but this time we're going to talk about having 50 students. So I'm going to graph it. Oops. X will be buses. Nope, X will be students. Excuse me. And our Y will be buses. So I'm going to go up by 50s for students. 50, 100, 150. And I'll go up by 1s on the side for buses. If we have 0 students, we need 0 buses. So I can put a point right there. But as soon as we have 1 student, we need 1 bus. So you can think of this as, remember when we were graphing something like x is greater than 3? So we'd have 3, 4, and we'd have our 2 on the other side. They're not equal to 3, but as soon as it gets over 3, so like 3.000001, right? As soon as it gets over 3, then we want to include it. So we would do an open circle and then draw in our line. Same sort of deal here. As soon as we just get over 0, in this case as soon as we get to 1, but sometimes in other cases as soon as we get to like 0.001, we need to have 1 bus. So we put a circle there and draw it over. And the most we can have is 50 students on a bus, right? If we have 50 students, we can have 1 bus, but any more and we'll need another bus. So we have a point at 50, 1. 50 students, 1 bus. As soon as we get to 51, that's when we need 2 buses. And on 2 buses, we can have up to 100 students. And then as soon as we get 101, we need a 3rd bus. and it would continue on like that. Not all step functions start with the whole and end with the dot. Sometimes you'll start with the dot and end with the whole. It just depends on the situation. And there's your homework.